Hi guys, today we're going to be talking about surface area and lateral area of pyramids and cones. So we already talked about what a vertex is. It's where three or more edges meet. We know that a regular pyramid is a pyramid where the base is each of the sides of the base are congruent. The slant height of a regular pyramid is going to be the height, basically what it sounds like. So right here, I kind of drew a picture for you. That's going to be the slant height. That's different than the actual height, which would be this down here, which would be straight up and down. It would be the altitude. If you were to connect the altitude and the slant height, it would form a right triangle. And that's really bad, but you get the point. That's supposed to go through the center of my base. But basically the slant height would be the hypotenuse of that right triangle. The vertex of a cone is the same as the vertex of the pyramid, except that it's not really formed by lines. It's just going to be the top of the pyramid, so the cone rather. So it'd be right here. This would be the vertex of the cone. Now, in a right cone, we have a slant height and we have a height, right? Because it forms a 90-degree angle, and you're able to draw that right triangle from the center, right? Now, the difference between that and an oblique cone is that an oblique cone, which is right here, you have a height, but you don't have a slant height. So it's basically a cone that's kind of tilted to the side, or it's kind of leaning on the side. The lateral surface area of a cone is the surface area of everything of the cone except for the base. Kind of like when we were talking about prisms. It's the same thing, except in this case you're excluding one base instead of two, since a cone only has one base. So moving on, the lateral area and surface area of a regular pyramid. In order to do this, the lateral area is going to be L equals 1/2 times P, which is the perimeter of the base, times L, which is the slant height. Okay, so you'll do 1/2 times the perimeter of the base times the slant height. For surface area, you're going to do the base. There's only one base this time, so base plus the lateral area. So it would be base plus, again, we know that the lateral area is 1/2 perimeter times slant height. For a cone, it's the same thing, except since I know that the bottom, the circumference of a circle is basically the perimeter, right? So if we did 1/2 times 2 pi r, the 1/2 and the 2 would cancel, which is why it becomes pi r times the slant height. And similarly, the surface area would still be base plus the lateral area. So the base of a cone is a circle, and we know that the area of a circle is pi r squared. So we'd do pi r squared plus the lateral area, which is pi r times the slant height. For this next part, we're asked to find both the lateral and surface area of the regular pyramid. We know that it's regular. Because it's regular, we know that all of the side lengths of the base are going to be congruent. So if one side is 18, then all of them are going to be 18. Now let's start off with the lateral area. We know that lateral area is 1/2 times the perimeter of the base times the slant height, right? So I'm going to do lateral area equals 1/2 times the perimeter, which in this case we would do 18 times 6, since this is a hexagonal pyramid. So 18 times 6, and then times 17, which in this case is the slant height. So then I would get that my lateral area is 918. For my surface area, I would do my lateral area plus my base, right? I already know that my lateral area is 918, so I know that it's going to be 918 plus my base, which I know that the base of a hexagon is going to be 1/2 apothem times perimeter. So in order to find this, I'm actually given my apothem this time, which is very rare. Most of the time you're actually going to have to find the apothem. But they were nice enough to give us the apothem. and then times the perimeter. So it would be S equals 918 plus 1/2 times the apothem of a 9 root 3 times the perimeter, which is just going to be 18 times 6. Whenever you put that into the calculator, you do get that S is equal to approximately 1759, so 1759.77, and that is square feet. All right, and I forgot to include that here. I'm really bad about my units. Okay, looking at this next one, let's start off by finding the lateral area. By the way, if I were you, I would definitely pause and try to do these yourselves before continuing, just to make sure that you understand how to do it. But anyways, that's up to you. So for question 2, my lateral area, once again, is 1/2 times the perimeter of my base, which is actually 2.4 times 3. Since I know that it's a regular pyramid, all the sides are going to be the same, so I'm just going to do 2.4 times 3 for the perimeter, and then times my slant height, 3.7. So for my lateral area, I get that my lateral area is approximately, or actually is exactly, 13.32, and that is millimeters squared. For my surface area, my surface area is going to be my lateral area plus the area of my base, right? So I'm going to do 13.32, that's my lateral area, and then plus my base, which I know that my base is going to be 1/2 base times height, since it is in fact a triangle. All right, so if I look at 1/2 base times height, the base of my triangle, the area of the base of my triangle, I know the base is 2.4. I don't know the height. So in order to find the height, I'm going to use Pythagorean theorem. I kind of already drew this out over here. So I know that my hypotenuse here is 2.4. So I'll do 2.4 squared is equal to 1.2 squared plus h squared. Whenever you solve for h, you end up getting that h is 6 root 3 over 5. I do not want to put that in decimal form just yet, because remember, we need to keep everything in exact form until the very end. So back over here, I have that my surface area is 13.32 plus 1/2 times the base, which is 2.4, and then times my height, which is 6 root 3 over 5. I'm going to put that into the calculator. Once I put that into the calculator, then I can round it, because that is going to be at the end. So then you do end up getting that your surface area is approximately 15.81, and that is millimeters squared. All right, moving on to this. So over here it says a square pyramid has a height of 16 centimeters and a base edge length of 60 centimeters. I'm going to go ahead and draw this. You can pause to draw this as well. Okay, so a square pyramid has a height of 16 and a base of 60. We're once again trying to find the lateral and surface area of this figure. Let's start off with the lateral area. I know that the lateral area is 1/2 times the perimeter of my base times the slant height. Now, if you look over here, we're actually missing the slant height. We're given the regular height, we're not given the slant height. Now, we could always draw a right triangle that gets us to the slant height, right? So in this case, the slant height would be the hypotenuse. Now, if I know that the entire side length is 60, then I know that half of it would be 30. So if I was to redraw this triangle, just this triangle over here, I would know that this right here is 16. This is 30. So now I'm trying to find my slant height. So I'm just simply going to use Pythagorean theorem. And when you do, you end up with your slant height is equal to 34. So I now have that using Pythagorean theorem. I didn't show it. I'm assuming that you guys already know how to use Pythagorean theorem. So it would be lateral area equals 1/2 times the perimeter, which in this case, the perimeter would be 60 times 4, and then times my slant height, which is 34. So then you end up with your lateral area is 4,080. And that is 4,080 centimeters squared. Okay. For the surface area, my surface area we know is going to be base plus the lateral area. That's pretty simple. Since this is a square pyramid, the base is a square, so you're just going to do side length times side length, or you could do side length squared, right? So you'll do S equals, I'm just going to do 60 times 60, and then plus my lateral area, which is 4080. When you do this, you end up with your surface area being 7,680 square centimeters. All right, so down here, we're asked to find the lateral and surface area of these cones. So once again, we are going to be using that the lateral area of a cone or of any cone or pyramid is 1/2 P times L. But as you know, since the perimeter of a cone is technically the circumference, whenever we do 2 pi r times 1/2, the 1/2 and the 2 end up canceling. So then it's just going to be lateral area equals pi r times the slant height. And then the surface area is still base plus the lateral area. So for my lateral area, let's start off with that. I'm going to do pi times my radius, which is 6.3, times my slant height, which is 10.4. Now, the exact form of this is 1638 over 25 pi, which simplifies, which whenever you plug that into the calculator, that ends up being 205.8, and that is inches squared. Now, this is what you would type into the into a test, depending on what they ask you to round to. I rounded to the nearest tenth, but I'm just putting that in for lateral area. Now, when you go back in for surface area, when you add it together, you do need to make sure that you're using this before you simplify your final answer. Okay, so for my surface area, this is kind of the example here. So my surface area is going to be my lateral area plus the base, the area of the base. So I'm not going to use 205.8. I'm instead going to use 1638 over 25 pi, and then plus, and then the base, so that's going to be pi r squared. So you'll do 6.3 squared times pi. And then whatever you get here, that's what you'll round. So you'll plug that into your calculator, and you should end up with something like this. 330.5 is what that rounds to, inches squared. Okay, let's look at this next one. For this next one, we are given the diameter. So if we're given the diameter, we also know the radius is just half of the diameter, so I know that this is going to be 20. We're not given the slant height. So in order to find the slant height, I'm going to do Pythagorean theorem. So you'll end up with 21, square root of 21 plus 20 squared. Both of those are squared. And then when you plug that into the calculator, you end up getting 29. So I know that my slant height here is 29. So for my lateral area, it's going to be pi times 20 times 29. Because remember, it's going to be the base, so it'll be pi r times the slant height. So then you end up with your lateral area is 1,822.1. And then for my lateral area, remember for your surface area, remember to keep the lateral area in exact form. This right here was rounded, so I'm actually not going to use that. I'll use this instead. So I've got my lateral area, which I'm just going to say is pi times 20 times 29. You could multiply 20 times 29 if you wanted to, but you know. And then plus the base of my cone, which is going to be pi r squared, so that's going to be 20 squared times pi, You'll put that in the calculator and you will end up with approximately 3078.8 is your final answer. For this next part, it says a right cone has a diameter of 17 feet and a slant height of 9.6 feet. So for the lateral area, we know it's going to be pi times the radius times the slant height. Now they give us the diameter, right? So the radius would actually be half of the diameter, which in this case would be 8.5. So it'd be pi times 8.5 times 9.6, and that will give you approximately 256.4. And then for the surface area, remember you don't want to include this because that's rounded. You're instead going to type that in for the lateral area. So I'll do pi times 8.5 times 9.6, and then plus the base, which we know is pi r squared. So I know that it's going to be my radius, we know is 8.5, so it'll be 8.5 squared times pi. So when you add these two things up, you end up with approximately 483.3, and this is all feet squared.